Okay, here we go. All right. Chapter 6. 6.1. Okay, counting methods and the pigeonhole principle. All right, so here's, we're going to do some, basically, this is like an introduction to probability theory, more or less. So imagine in this scenario here, here's a restaurant, right? And you've probably seen this example. And the question is, how many different meals are there if you choose one appetizer, one main course, and one beverage? And well, here's a list of them, but there's the easy way to calculate the number of them. You just simply multiply the number of choices for the first thing times the number of choices for the second thing times the number of choices for the third thing in this case. Okay, and this is what's called the mathematical multiplication principle. So if you're in a situation like this, what is that situation? So if an activity can be considered in t successive steps, right? And if step one can be done in n1 ways, step two can be done in n2 ways, dot, dot, dot. And if step t can be done in n sub t ways, then the number of different possible activities is, well, you just multiply all those numbers together, okay? So, all right, let me do some examples here. Oh, here we go. Let's look at this example. How many strings of length 4 can be formed using the letters, let's see, A, B, C, D, and E, if repetition are not allowed? Okay, so what does that mean? Well, we would have to choose a number for the first place, right? And there's 5 choices, so there'd be 5 ways to choose that number. And then we would choose a letter for the second spot, but we reduced the number 5 to 4 because we don't want to have any repeats. So it'd be 5 times 4 times 3 times 2, right? So right here you can sort of see it's 120. Okay, how many strings in part A begin with the letter B? Okay, well, let's see. To do that, if it begins with the letter B, that means we only have one choice for the first one, and then we have 4 choices for the second one, 3 choices for the third one, and 2 choices for the last one. So it's 24. So that's the number that begins with B. It says how many strings in part A do not begin with the letter B? Okay, so all right, I guess there's at least a couple ways to do this. I would say you could do it this way. Well, if it doesn't start with a B, that means you have 4 choices for the first letter, right? And then you would have, well, then you throw B back in the mix, and then there's 4 choices for the second letter, and then there's 3 choices for the third and 2 for the last letter. Another way of doing it is it says how many strings in part A do not begin with letter B. Well, if we calculate how many of them start with a B, I guess that's probably with that. Like we know there's 24 strings start with a B, and if we know there's 120 total, then it'd be 120 minus 24. Would be another way of getting 96. Okay, here's another example. In a digital picture, we want to encode the amount of light at each point as an 8-bit string. How many values are possible at one point? Okay, so if it's an 8-bit string, and we want to encode that, we know that we get to choose a 0 or a 1 at each spot, right? So that'd be right here, you see the calculation, 2 to the 8th, or 256 different possible ways. Okay, let's see. Another example. Use the multiplication principle to prove that this set containing n elements has 2 to the n subsets. That is, that the cardinality of the power set of an n element set is 2 to the n. Okay, so if you have a set A, how do you determine that? You would determine the set contains elements. So you look at each element, you say to yourself, is x1 in there, x2 all the way up to xn, right? And there's so I'm not saying this properly, but what you need to do is if you're counting them out, you have 2 choices, right? it's either in or not. You decide to pick it or not, right? So let's take a look at, so a subset can be constructed, right, in n successive steps. I guess that's what I want to say, right? We pick or do not pick x1, right? We pick or do not pick x2. There we go. Pick or do not pick xn. So you decide which ones are in there. Now, each step can be done in two ways, right? So thus, if using the multiplication principle, the answer is 2 to the n. So sorry for fumbling through that one. Okay, let's take a look here. What's this one? How many 8-bit strings begin with either 101 or 111? Okay, so I drew this little thing here, I guess, right? So how do we do that? So you get two choices here, right? Either this or that. So that would be 2. And then here you have to pick a 0 or a 1 for each of these remaining spots, right? 1, 2, 3, 4, 5. See, okay, look at this. This is a good example. I'm doing this differently. I'm thinking what I'm doing. I'm not doing this solution, I guess. I'm thinking of that's one. You choose this or you choose this, and then you choose the 5, right? 1, 2, 3, 4, 5, and that gives you 2 to the 6th, which is 64. What they're saying here, I guess, I'm just looking at their solution, they're coming up with 32 because they're saying an 8-bit, okay, so an 8-bit string that begins with 101 can be constructed in 5 successive steps, and that's choosing the next 5. And then they're saying, well, if you chose the other one, you'd get another 32 to get to 64. So I guess what you're seeing is you can actually, there's typically different ways of coming up with the same answer, and hopefully you're doing the calculation correctly. So anyway, all right, the addition principle. Okay, so this is an important one to know, and it's also important to keep in mind that these sets are not intersecting. So what does it say? Suppose that we have x1 through xn are sets, and that the ith set xi has n sub I elements. If x1 through x sub t is a pairwise disjoint family, that means that none of these sets intersect, right? Then the number of possible elements that can be selected from x1 or x2 or blah, 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 is, and you simply add that up, x1 through xn, all right? Equivalently, what they're saying is that the union of all these sets contains n1 plus n2 plus, all to n sub t. Okay, so let's see, and that's pretty clear. I mean, it's a disjoint union, so you just add up the elements, you get more elements. Excuse me. All right, right after that, I wanted to talk about this inclusion and exclusion principle, okay? So that's not always the case. You see, if you have two sets, x and y, it's possible that they have this intersection is not empty. In other words, there might be things that are in common to both. So the question is, how do you calculate the size of their union? You see, if you simply just add the number of things in x plus the number of things in y, then you're actually going to be counting the things in their intersection twice. So the correction is that here's the formula: the order, or the number of elements in x union y, is equal to the number of units in x, number of units in y, minus, or the number of units in their intersection. Okay? That's called the inclusion-exclusion principle for two sets. Okay? And, okay, so that'll get us started. And you can do some problems in 6.1, and then we're going to learn more techniques as we go on here in Chapter 6. So, thank you.